let us take a stroll along the floating point number line. We have our number line here. 0 is at the centre. Everything to the right is a positive number. Everything to the left is a negative number. In this video we're going to start off at the right hand side here. So we'll start off at the largest normal number. By that I mean the largest positive normal number. And we're going to work our way to the left here. So we're going to work our way along the normal number line until we get to the junction between the normal and the subnormal. Then we're going to work our way along until we get to the junction between the smallest subnormal number and an underflow to 0. And then we're going to continue along until we get to the underflow to minus 0 and the junction between that and our negative subnormal numbers. And we'll continue along until we get to the junction between our negative subnormals and the normal numbers. And finally we'll get to the very left hand side where we're going to get the junction between our negative normal numbers and our overflow to minus infinity. So it's a good idea to work your way along the number line and have a look at the junction between each of the number types. You'll note here as well I've put the numbers in hexadecimal. So this number here is the largest normal number, and I've put the largest normal number up here, and you can see here that the F is going to be the first 4 bits here, which are 1, 1, 1, 1. So it's much easier to see what we're doing whenever we put the numbers in hexadecimal. Otherwise we would have 32-bit numbers all over this and it wouldn't look very good at all. So let's run up our conversion tool and we'll have a look at this junction here. So let's look at our largest number in the conversion tool here. So I'll start off by populating the exponent. Now you can see the exponent here is going to be a value of 254. So the least significant bit remains at a 0. So we've got 254 here and we take away the bias, which is 127, and this will give us an exponent value of 127. So it means that we have moved the window furthest to the right, so the very last power of 2 to the right is 2 to the 127, so we're in that window. So now what we want to do is we want to generate the largest possible number within that window. In order to get the largest possible number within that window, we have to get the largest possible mantissa value. So that's going to be all 1s on the mantissa. So let's say for example we pick the first one here. So we're going to have the mantissa as 2 to the power of minus 1, which is 0.5. And then we'll get 2 to the minus 2, 2 to the minus 3, and you can see each time we're adding it on and we're getting a number that's getting close to the value of 1. But it never ever quite makes it to the value of 1. In fact, it goes all the way along here to 2 to the minus 23. So it means that the number that we generate here isn't the number 1. It's 1 minus 2 to the minus 23. So we're just out by that tiny amount, 2 to the minus 23. So we take this mantissa value here and we add 1 onto it. So it's 1 plus the mantissa value. We multiply that by 2 to the 127, and we've also got our result here for our sign, so it is a positive number. If we had to make that 1, it would become a negative number. So we've now got the largest possible number that we can generate, and this is the number here. So let's say for example I wanted to go one number beyond this. So in order to go one number beyond this, we would have to take the window that began at 2 to the 127, and we would have to shift it up to a window at 2 to the 128. So in order to do that, we would make all of the mantissa values 0 again, and then we would have to attempt to shift the window up to the next exponent value. The next exponent value is going to be 255. So if we make this the next exponent value, we click on it, you'll see here that what happens is we overflow to plus infinity. So any number that goes beyond that number will overflow to plus infinity. So let's go ahead and we'll have a look at our largest number in a bit more detail. So our largest possible normal number is going to be given by the hex value 7F7FFFFF, and this is it written down in binary, and we've seen this number converted in the conversion tool. So we said that the largest number that we can get is going to be 2 to the power of 127. But it's not going to be exactly equal to 2 times 2 to the 127 because we never get to that value of 2. We only ever get to a value which is 2 minus 2 to the minus 23. So whenever we multiply these numbers together, we're going to get this number here, 3.4028234663859 e to the plus 38. And this here is going to be the largest possible normal number that we can represent in a single precision floating point number system. So that is approximately equal to 2 times 2 to the 127. So sometimes when you look online and you're looking to find the largest possible normal number, sometimes it's written like this. Now it's not quite right because it's an approximation and it's out by a factor of 2 to the minus 23. So let's look at this mathematically. If we say that this number 2 is something called the radix, so the radix is 2 and we'll give that the value beta. So we can say that the value of beta minus the value of beta to the power of, well, we've got 1 minus p here. So the number p is actually the number of significant figures. So the number of significant figures in the significant isn't actually 23, it's actually 24, because there's one of the bits is going to be a hidden bit. So what we would say is 1 minus 24, which is actually minus 23, and that's times the value beta to the power of our maximum value here, which is our bias value. So the maximum bias value, our single precision floating point, is going to be 127. So this is how we see the maximum possible, the largest possible normal number represented mathematically. So that's all there is for this video. In the next video we'll go down and we'll look at the next junction here, which is a junction between the normal and the subnormal numbers. So thank you for listening. I'll get you in the next video. Goodbye.